All right, so around the time that Marie Tharp proposed this idea of a rift valley, and slowly over time, we found more and more evidence that other people began to believe her. Still at this point, we only had evidence for divergent plate boundaries where the plates separated. At this point, they still didn't have evidence for convergent plate boundaries. They didn't know about subduction zones. So let's look through the additional evidence that allowed them to create the entire theory of plate tectonics, not just the mid-ocean ridges, but also the subduction zones, not just the divergent plate boundaries, but also the convergent plate boundaries. Okay. Now, one of the things that really helped Marie Tharp's theory was paleomagnetism. Earth has a magnetic field, right? Because of the liquid in the outer core and the iron in the core, there's this rotating electrons in the core, which creates this magnetic field around Earth. You can think of Earth a lot like a bar magnet, right? With a positive side and a negative side, creating this electromagnetic field around the Earth. Now, when lava erupts from the rift valley on the seafloor at the mid-ocean ridge, the iron-bearing minerals within that fluid are able to orient themselves within that fluid and align with the Earth's magnetic field. Right? They're basically tiny little compass needles in the lava. After they solidify, those compass needles get stuck in that rock. They're no longer able to move around as they were able to in the fluid. They get stuck in that orientation. So whatever orientation the North Pole is at when that rock is created, that's the position that that rock stays, the iron-bearing minerals within that rock stays. Now, what's interesting is that Earth's magnetic pole periodically switches, right? So today our compasses point north. Periodically throughout geologic time, that has switched and our compasses would have pointed south. So normal polarity is when our compasses point north. Reverse polarity is when our compasses point south. As a result of this, we find stripes of normal and reverse polarity on the seafloor, right? Material is erupted. If there happens to be normal polarity, all of those iron-bearing minerals point north. And then they are moved away from the mid-ocean ridge. And then after some time, when our poles reverse, our magnetic poles reverse, the new material coming out of that rift valley, that mid-ocean ridge, will point south and then be spread away from the mid-ocean ridge. And this happens over and over and over again, that we get parallel stripes of magnetism on our ocean floor that allows us to date the age of the ocean floor. So paleomagnetism helps us date the age of the ocean floor and allows us to see that it gets older as we move away from the mid-ocean ridge. This was a really big line of evidence that proved Marie's theory, or proved her hypothesis. It wasn't a theory yet. Now, not only do we have paleomagnetism, we also have evidence of subduction zones, and this is with the Ring of Fire. The Ring of Fire is the ring around the Pacific Ocean where there are just tons and tons and tons of volcanoes and earthquakes, way more highly concentrated than anywhere else in Earth. And this showed us that there's active tectonics happening here. We know now this is where old oceanic lithosphere, after it gets old and cold and dense, sinks beneath the less dense continental lithosphere. Right, so we have subducting tectonic plates creating these volcanoes and earthquakes. Right now, we have these maps of plate tectonics on Earth, right? All of the different colors on this map are showing the different tectonic plates. Notice that some are huge, like the Pacific plate, some are tiny, like the Juan de Fuca plate, but all of them are floating on top of the mantle, moving around, bumping into each other, being created new at divergent plate boundaries, and that old material is being consumed back into the Earth at convergent plate boundaries. And all of this information was realized just in the past several decades.